Hi, I'm Cody Saunders. I'm here to talk about the soft-wheeled mobile robot with a shape-morphing steering mechanism. So basically, we're doing a soft robotics project here. Basically, soft robotics are different than traditional robotics is that traditional rigid robotics only really allow for translation and rotation, whereas soft robotics can have like bending, twisting, flexing, and stuff like that as part of the design. So they allow for much more complex, uh, more dexterous, bio-inspired movements compared to like robotic stiff movements that you would typically associate with robots. And basically what we imagine for this system is we'd have a cylindrical uh, body which inflates sequentially, which allows it to rotate. And then we, as well as having a shape-morphable wheel, which basically is a wheel that you can inflate and it increases its radius, so which allows it to turn depending left or right, depending on which wheel you inflate or morph it, if you will. And so here's our basic modeling equations for our robot. As you can see here, we have the unmorphed wheel and the morphed wheel. And there's kind of as it's rotating around a fixed point due to its increased radius here. So for our system, we did kinematic and dynamic modeling of the robot, which we developed via the equations over here to the right, and simulated via MATLAB to analyze the motion of our robot to see if it was feasible. Then we did our preliminary design and prototyping, which we carried out by use of CAD and 3D printing. And then we also had to develop a pneumatic control system using our Arduino microcontroller, which would control the air pressure and airflow direction via use of three-way valves, MOSFETs. So here's some of the kinematic dynamic modeling that we accomplished via MATLAB. So as you can see here, it's rotating around a fixed point due to the how it's slanted with one face constantly on the ground, and it causes it to have like a rotation like that. Okay, so let's talk about more kinematic modeling. So basically, here's a scenario that we modeled via MATLAB. So basically, we have a scenario here where they have the same radius, which causes it to go straight. We decrease radius 1, keep radius 2 the same. That causes a right turn. And then we have the reverse scenario. R1 is double that of R2, and it causes a left-hand turn. And then, as you can see, as you vary them, it causes a zigzag path here. So the morphing wheel is the steering mechanism, as you can see. Basically, here's it in its resting state, and then after it's inflated, it's increased the radius from like here to here, and then that's what causes the increased radius is what causes it to turn. So here's the pneumatic control of the rotating cylinder part of the robot. Basically, these are three-way valves here that are fed from this exhaust manifold. And basically, the MOSFET is controlled or turned on and off by this Arduino controller right here. And we have a power supply over here at 12 volts. And then the MOSFETs allow the power to come through the gate and turn on these and turn them back off. And since these are three-way valves, we have air coming from here into there, and so that can also exhaust out of here or exhaust out of here, or well, that's actually the intake. And it intakes there and exhausts out to here or here, depending on what the state of being on or off. So here was our clip of the robot rotating. As you can see, as each little section inflates, forces it over further and further, so it's causing it to rotate. So our kinetic and dynamic modeling showed the feasibility of the proposed shape-morphing robot. We were actually able to build all the different systems, including the pneumatic controller, all the soft actuators, the control system, and the inflatable sections. So our next phase is to incorporate both systems onto a single model. As you can see, we want to thank NASA New Mexico Space Grant Consortium, and we also want to reference our references listed below. Okay, thank you for your guys' time. Have a great day.